Namaskar, hello and a very warm welcome to our webinar series of Listening to Learn. My name is Tanvi Khurana और इस वक्त आप हमें देख रहे हैं PM ई विद्या चैनल नंबर 9, चैनल नंबर 10, चैनल 11 और चैनल नंबर 12 पर। इस प्रोग्राम में हम बातचीत करते हैं किसी ना किसी टॉपिक पर जो कि साइंस रिलेटेड होता है। आज तक 1 साल से ज्यादा हो गया है इस कार्यक्रम को और हमने बहुत सारे टॉपिक्स पर बातचीत की है, चाहे वो हेल्थ और न्यूट्रिशन हो, विंड टनल्स हो, जियोफिजिक्स हो या और बहुत कुछ। स्पेस पर भी हमने बातचीत की है, पर आज जिस टॉपिक पर हम बातचीत करने वाले हैं वो है बैटरी मैन्युफैक्चरिंग इन इंडिया, टेक्नोलॉजिकल चैलेंजेस एंड अपॉर्चुनिटीज। हम सभी जानते हैं कि बैटरीज बहुत सारी चीज़ों में इस्तेमाल होती हैं, चाहे वो गाड़ियां हो, चाहे आपके रिमोट हो, इन्वर्टर्स हो, बच्चों के खिलौने हो, कैमरास हो या फिर जो रिसेंटली लॉन्च हुई हैं इलेक्ट्रॉनिक व्हीकल्स, ईवीज जिन्हें हम कहते हैं। हर चीज़ में बैटरी का इस्तेमाल होता है, पर उसके पीछे जो मैन्युफैक्चरिंग का प्रोसेस है वो कितना इंपॉर्टेंट है, और साथ ही साथ डिस्पोजल का प्रोसेस, जब वो बैटरीज काम नहीं करती तब उनका क्या होता है, क्या वो एनवायरमेंटल सेफ हैं, ये हम जानेंगे हमारे आज के एक्सपर्ट से। अगर आपके पास अगर कोई भी सवाल हो तो आप हम तक जरूर पहुंचाइए। यू कैन कॉल अस ऑन आवर नंबर विच इज 8800440559। At this moment, you're watching us on our YouTube channel, which is NCERT Official. In the live chat box, write down your questions, queries और हम तक पहुंचाइए। 11 बजे तक हमारे एक्सपर्ट हमारे साथ मौजूद रहेंगे और उन्हें बहुत खुशी होगी आपके सभी सवालों का जवाब देकर। उससे पहले हम आपकी मुलाकात करवाना चाहेंगे हमारे आज के कार्यक्रम के मॉडरेटर और जो रियल होस्ट हैं, और वो हैं डॉक्टर गगन गुप्ता। स्वागत है सर आपका।
धन्यवाद तन्वी जी, धन्यवाद।
सर है डिपार्टमेंट ऑफ एजुकेशन इन साइंस एंड मैथमेटिक्स NCERT से, और हम आपको ये भी बताना चाहेंगे इस कार्यक्रम को पूरा आयोजन करने का जो श्रेय जाता है वो भी DESM को जाता है। तो चलिए हम आज के हमारे स्पेशल गेस्ट का परिचय आपसे जरूर करवाना चाहेंगे। हमारे साथ हैं डॉक्टर वेनीमाधव आद्यम। सर हैं क्रायोजेनिक इंजीनियरिंग सेंटर से, जो कि है इंडियन इंस्टीट्यूट ऑफ टेक्नोलॉजी खड़गपुर से। और अब मैं सर को इंट्रोड्यूस करना चाहूँगी। गगन गुप्ता सर से रिक्वेस्ट करना चाहूँगी कि सर आप हमें थोड़ा सा एक ब्रीफ हमारे दर्शकों को दीजिएगा कि जो आज का टॉपिक है उसमें हम क्या बातचीत करने वाले हैं, और साथ ही साथ हमारे जो स्पेशल गेस्ट हैं उनका भी एक ब्रीफ इंट्रोडक्शन।
जरूर। Thank you Tanvi ji, thank you friends and all viewers. You know that this program is going on air since last 1 year or so. We have completed 39 session. Today it is 40th session of this series, and we are doing this session in collaboration, in active collaboration with the CSIR Prabhas, that the Prabhasi Bharatiya Academic and Scientific Sampark program, which was started nearly 2 years ago during this COVID period for connecting scientists outside India with the motherland. In this series we have that the NCERT has taken up this program very rigorously, and almost every fortnight we are organizing this session. So far, as Tanvi ji has said, that we have taken such topics on space, health and nutrition, Indian ancient knowledge. हमने दिल की सैर की है इस प्रोग्राम में। हमने इस प्रोग्राम में काफ़ी सारे सेशंस किए हैं। लास्ट वीक हम विंड टनल्स को देख रहे थे, लास्ट वीक हम विंड टनल्स पर बात कर रहे थे, उससे पहले हम जियो फिजिकल इंस्पेक्शंस की बात कर रहे थे, एंड सो फार सो ऑन। आज हमारे साथ हैं प्रोफेसर Venimadhav, a young man from Indian Institute of Technology, Kharagpur. He is presently heading the cryogenic center. Before I formally introduce Venimadhav with all of you, friends, let me just make a small start with this session. Look at the batteries manufacturing. It is being said we have been using lead acid batteries. We have been using lithium-ion batteries nowadays. It is being said that these the manufacturing of these processes as well as the disposal of these batteries involves lot of environmental unfriendly mechanisms, and this is a challenge for climate change, etc. Now we have lithium. Nowadays we are using lithium-ion batteries, which are lithium is a rare material. It's not easily available. India is dependent on many other countries, Afghanistan, China, etc. For importing this lithium metal from them, and nowadays we are trying, the Indian scientists are involved, very actively involved in finding an alternate to lithium-ion batteries and these batteries would be called as sodium-ion batteries. Sodium is easily available in this country, in our country, and that will be very cheaper, and it is expected that the sodium-ion batteries will be much more environment friendly as compared to these lead acid or helium-ion or lithium-ion batteries. So with this, let me introduce Professor Venimadhav Adyam to all of you friends. Dr. Adyam, Venimadhav Adyam is the professor and head of the Cryogenic Engineering Center at Indian Institute of Technology, Kharagpur. He obtained his PhD in 2001 on the investigation of electrical and magnetic transport properties of perovskite related metallic and magnetic oxide thin films and multilayers from the solid state and structural chemistry unit of the Indian Institute of Science, Bangalore. Dr. Adyam has been with the Department of Material Science, Cambridge University, United Kingdom during 2001 to 2004 as a postdoctoral fellow, and with the Department of Physics, Pennsylvania State University, United States during 2005 to 2007. At both these places he was working as a postdoctoral fellow and of course as a visiting professor too. The research interests of Dr. Adyam include quantum materials and devices, thin films, sodium-ion batteries and micro batteries. Dr. Venimadhav has also undertaken various research proposals funded by the different agencies for pursuing active research in these areas. Dr. Adyam has so far 7 patents to his credit and has co-authored 3 book chapters and has published 110 research articles in peer-reviewed journals of international repute. Dr. Adyam is equally a passionate teacher at the IIT Kharagpur and has developed 5 new courses and has set up a number of teaching experiments. Dr. Venimadhav is a recipient of the MRSI Medal Award of the Materials Research Society of India, DST, Department of Science and Technology, Government of India, DST Fast Track Young Scientist Project 2009, and Engineering and Physical Sciences Research Council, that is EPSRC, Postdoctoral Fellow in 2001. So let us welcome Dr. Adyam to this platform. So it's all yours now, Dr. Adyam. We are very happy in having you here. We thank Indian Institute of Technology, Kharagpur for collaborating with us in this program. And yes, it's all yours, Professor Adyam.
Thank you very much, Ganesh. I mean, it's a very lengthy introduction. Thank you very much. Now I think I can start, and I have about I'll talk for about 45 to 50 minutes, and then I'll take the questions and as per what I have suggested. And my dear students, and I think this is from class 9 to class 12, very excellent time for the students to know the new things, because I'm in research today because of my visit to Atomic Research Center in when I was studying class 7. There I visited the center, and then I felt that I should do something like that. I mean, at that age, whatever you try to see and try to imagine, I think you can really make it to the goal. I mean, today I'm here because of that particular one visit. And you know, I'm listening to one good lecture also, you know, I know you've been listening to it, where you are seeing actually what is happening around us in terms of the batteries, and you listen to a lecture like this, then you will find that, you know, this is the area where India actually needs very bright minds today. I mean, KV is the one which produces one of the schools which produces very good students. So you should be focusing very carefully, and I'm very happy to answer your questions. And I have made my talk such a way that, no, it is not too much of in-depth of science, but what I try to do is every slide of mine today will have at least one picture. So because for students, I know you guys must have seen lots and lots of cartoons, so your way of looking at things and grasping things are very different from us. So I tried my best to show you, you know, in your own style, but let me try that. Okay, I'm not sure, but that's my style. So here I start. There is a big challenge for us, the battery manufacturing, because as you see today, there is so much of development needed. At the same time, there is ecological balance is also taught. If I show you that first slide, and these are my students and some other people also who help me in my research work. And you see the ecological presentation versus development, you see that there is something you need to take a call. So at the same time, you need development, but you should not destroy the world where we live. So whatever the process, which means that whatever the process, whatever the development we do, that has to be eco-friendly. So now the reason why I am putting this slide for the battery is that today we know that we are saying that no, we get away from the petrol-based or diesel-based cars, and we are moving towards the EVs. But how safe are the EVs? I mean, to the environment, have you asked the question? So, as such, the batteries is not the problem. The problem lies is in the process of making the battery. So, this process should be eco-friendly as well, and also the materials that we use that also should be in line with the eco-friendly nature. So, and for that, electric vehicles, the reason why we talk many times is that though we have several other applications, we talk about electric vehicles because these are the ones when they are going to roll on the road, then you will have plenty of batteries to be made. For example, just think about Indian trucks running and Indian buses and Indian cars with this population running with so many batteries. We need to produce so many batteries. You see that the market is huge, really huge market. And there are so many possibilities. People can come with different chemistries and you can catch it. But at the same time, you should take care of three things. One, for a company, anyway, it's a company's interest, it should be as cheap as possible. Also, it is a customer's choice that it should be as cheap as possible, then only I'm going to buy it. At the same time, your process should be eco-friendly. Okay? Otherwise, it is not going to be, it's not going to be good for our future generation. And the third point is going to be, it should be absolutely safe. When I use it, there should not be any flows. Okay? These are the three things, when I think of a battery, a company or a user, these are the three things which are going to be extremely important. Now I come to the case of batteries. Batteries are all around us. So you can see the pacemakers, you look at the pacemakers or the pencil batteries that you use for your remote controls and stuff like that. The laptop batteries, some of you must be using the laptops, so laptop batteries and the car batteries. This is not for the running the car, this is just to ignite the car and some of the internal electricity, AC and all those things. For that you have a battery, which is you can see that. And at the same time, your mobile battery, I think you must have seen what is the mobile battery. So now you will have a question. So what is the difference between the pencil battery and my mobile battery? What is the difference between the pacemaker battery and the laptop battery? So each battery is different in its role, which means that to a given application, the battery manufacturer is going to cater. For example, if you look at the case of the microcells and the pacemakers, they have to stay for years together. Whereas if you take the pencil batteries, you can use it and you can throw it. Okay, so looking at these things, we can categorize the batteries into two. One is the primary battery and the second one and the secondary battery. The primary batteries are the ones which are going to be your the primary batteries are the ones which you use it and you can store them. So the lithium battery available, alkaline batteries are available, and the zinc batteries or carbon zinc batteries are available. Here, the couple person will charge it once, and then you put it, you use it, and once it's over, you will just throw it. Whereas when you go to the secondary batteries, there you charge multiple times. You charge it, discharge it, charge it, discharge it, you can do multiple times, you can do it. But any of the batteries, is the concept is going to be different? No. The concept is always going to be the same. The chemical energy gets converted to the electrical energy, and then you use the electrical energy, you throw in the case of primary battery. In the case of secondary battery, what you do is that you have a chemistry in such a way that you can charge it again, convert that to the chemical energy with electricity, and then use that chemical energy to your purpose later as a discharge mechanism. So, chemical energy and electrical energy are kind of, you are trying to play with the battery chemistry. This is the concept of the batteries. I have written here redox. Since you are in class 9 and 10, you must already have started looking at what is oxidation and what is reduction. So those reactions are possible. So a battery works on the principle of redox. Okay. So now I go for the secondary batteries. So in the case of primary batteries, one of the important things is that you need to know is that the shelf life is relatively large. Okay. And the capacities are very low. They are not very high capacity batteries. So You cannot, if you want to have an application, you need to put many of them together to use it. That's not very viable. So it is not good for many applications. So what you need to go for is the second type. So the shelf life is not very much. As soon as you buy batteries, you have to put it there. At the same time, but the life of the batteries are more, which means that shelf life and the normal life is different, because you can charge and discharge. How many times you can charge and discharge? You can discharge at least 3,000 times. This so the lithium-ion battery. You have lead-acid batteries which are very much available in India. As you can see, some of your UPS and all those things are running based on that. Your car batteries also lead-acid today. And the technology probably which is already in the market are the lithium-ion and the polymer batteries and the lithium phosphate-based batteries. These batteries are already present. There is something called 18650 I have written here. What it means is that this is the size of the battery, basically. A size like that is 18650 is the size of the battery. That's what we talk about. The prismatic batteries and other batteries are something they look like that. You can see that. That's the kind of batteries. So the prismatic battery, or then there is one more is going to be, one more battery is also possible, which looks like a prismatic battery. It is a pouch cell, we call it as a pouch battery. And these are the three kinds of batteries which are in the market. Let us see how to read these batteries. This is what the first thing you need to know before we understand about the batteries. The first thing we always look for is what is the capacity of the battery? Who decides the capacity? The capacity of the battery should be high, then I can use it now. So who decides the capacity? It is the chemistry which decides. Basically, it's like cathode, which is there, that decides the capacity of the battery. If it is low, it is low. High, it is high. So it is your best choice to choose the capacity of the battery. But you can read it in terms of the milliampere hour or what. That's up to you. I mean, it depends on the thing. Do you want to read it as a power, as the energy which you want to? And the second thing is the maximum voltage. So the maximum voltage is again decided by the cathode and the anode. So your chemistry is again going to decide the cathode and the way you choose, that is going to decide your capacity. And I'm putting it here, one of the Samsung and the Apple batteries. These are the places where they are given. You can read them. Before you buy batteries, you have to look at it. So higher the voltage, yes, it's good. Higher the voltage is good. And the nominal voltage means, average charging time, the voltage that it's going to see is going to give you that. So that is about 3.85 for a 4.2 volts or 4.4 volt battery of lithium. So Samsung lithium battery is something which I'm trying to show you. There's something more also. There is something like called SOS, the SOC, they call the state of charge. So state of charge is certainly when you go to a market, this is particularly important for the EVs. When you go for the EVs, this is important. Okay, I'll come to that point a little bit later, maybe. That's better. When I show EVs, I'll come to that. Okay, this is how you read the batteries. Okay, and now I'll show you the analogy of the battery, the charging and the discharging. What is it? Let us assume that you have a reservoir of water, which I'm showing it in the left-hand side. There is upper reservoir and the lower reservoir, and I'm opening the reservoir, and it is going to come down, and there is going to be a turbine which is going to rotate and which is going to generate the power. So that is discharging. I'm discharging the battery now, and then I'm taking the power and I'm utilizing it for it. Okay. Now water comes to the lower reservoir. So what I'm saying is, upper reservoir is the higher potential, lower reservoir is the lower potential. So now going from upper to lower potential, I have taken the charge. What is my charge? Here it is like water. I have taken my charge. So I have drained the battery. Now I have to charge it. How do I charge it? I'm going to put a pump and I'm going to put the water back into the reservoir. Okay. So this is the process of charge and discharge. That's exactly what you see on your right side. The where cathode has got lots and lots of lithium reservoirs. So these cathode, this lithium, I'm going to put a battery, or I'm going to put a source, and I'm going to take it out, and I'm going to put it on the anode side. What is that I have anode? Possibly graphite, which is very cheap. So I'm going to put it over the graphite, and now I'm going to remove the connection. Now charging is over. Now I'm going to discharge it. I'm going to plug into my application, and then it goes from anode to cathode. When it goes from anode to cathode, I'm using it, which means that now it is completely charged. Charge means I have higher potential. I put it there. I put the charge there. Now I can discharge. So this is the very fundamental, and this is most important. If all the students, if you understand this very carefully from today's talk, observe it. Okay, if you have any questions, you can ask me. Once you please write down your questions, then you can ask me. Okay. So now, then all batteries should be same. No, 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 all batteries cannot be same. What matters is the path. So I have charged up to 5 volts and I am coming to 0 volts. Now the way it is coming down, as you can see your tangent cell, which you must have studied in your classes, where you have zinc anode and the copper cathode, and you have something called a salt bridge you will put it. That is the path. If you don't have the salt bridge, then you cannot transport the ions. So the transport of ions is extremely important. What ions are we talking about? If it's a lithium battery, I am talking about the lithium. If it is a zinc battery, I am talking about the zinc. Okay. If you look at the primary batteries, the lithium primary batteries and the zinc primary batteries, the same way, principle is same. If it is a secondary batteries, then 5 volts, the way it goes, it has to come back. So your road should be as open as possible. You should not have too much of crowd there. So which means that as I have drawn the resistance here, your internal resistance of the battery should be as minimum as possible. Okay, this is extremely important. So the whole of the battery engineering, your cathode and anode will not change, my boys and girls. What changes is your road. How beautifully you put your road is what is going to decide your battery. This is where the technology is going to come. Technology 1, technology 2, technology 3, which I am going to show you. This is where the research is. We people like in IITs, we work on these things. Of course, I can also work on the new cathodes and new anodes. That's one part. But when I have so many anodes and so many cathodes, let me pick one of them each. Now let me work on this road, the ion transport road very well, and I can use it. So for that, you need to know what are the components of the battery very clearly. So this slide shows you, as I talked to you about the anode and the cathode, now I am introducing one more thing that is called the separator. Because the anode is conducting, cathode is conducting. If I put them together, it is short circuited, nothing is going to work out. So I need to put somebody in between them which is not conducting. So that is going to be your separator, which is going to be a polymer. Or even a simple paper will do, a normal paper will do, that can be a separator. Okay, it can be a separator. But however, is that going to do the charging, discharging? No, it is not going to do. What you need is an electrolyte. You need an electrolyte. Electrolyte is the place where you put the ions, and ions can be mobile. Okay, so that is going to be done by the middle one, as you can see that, this middle one. So this is going to be the separator, and then this liquid is going to be the electrolyte. When I put liquid into the separator, into the battery, then it is going to function. What it means is that, I have a battery like this, which I have already made it here. Now I'll put it down like that, cathode, anode, and separator are there. Now I'm going to put it like that, and I'm going to pour the liquid. What is the liquid? This is the electrolyte liquid. Then I'm going to seal it. Now your battery is ready. Without that liquid, the transport is not easy, because in liquids, the electrolyte resistance is very, very low, and that's the reason we need it. I hope you understand this part. These are the very, very fundamentals of the battery. These first few slides, what I'm talking about, these are all the very fundamentals of the battery. So the cathode is the place which decides. Cathode is the place which decides your capacity, and the anode is the one which is electrochemically possible, so that it should be at the lower potential, as much low as possible. But you cannot go very low. There are issues of discharge. There's going to be a problem. So cathode and anode together are going to decide your total voltage of the battery, and the separator and the electrolyte together are going to decide about how quickly or how slowly you can charge, or you can think about fast charging, fast discharging, one point, and second is internal resistance of the battery, and the life of the battery is going to be decided by these things. Okay, this is a very, very fundamental part of that. Let us look at one of the chemistries. Let us look at the lithium-ion battery, lead acid battery. The chemistry looks more or same. You have the redox reaction which is happening, and what is happening at the cathode is that your lithium you are going to take out from the cobalt oxide. So lithium cobalt oxide, you are going to remove it, and then you are going to put it there. You are going to apply a potential, and then when you go to the anode, what you are going to do is you have already put the lithiums in carbon, like it sits as LiC6, and then you are going to when you discharge it, that lithium is going to go and it is going to reach to the cathode side. This is the chemistry I mean, in the case both in the case of lead acid battery or the lithium-ion battery, it's the same thing. In the lead acid battery is the lead metal versus the lead oxide is what positive electrode, which we tend to do here. In the case of lithium battery, it is a lithium cobalt oxide, and the carbon is what we are going to cycle between. So this chemistry remains more or less same. However, as you can see, the voltages are different. These voltages are the electrochemical potentials, and this I am going to show you. If you open your NCERT books, then you have a big table which I am going to show you somewhere down. You have this in your class table, so it's already there. You can see that. Okay. So now look at the applications. What are the various possible applications? You have the consumer devices like the lithium for the laptops or for the remote controllers, or for these stationary applications, and particularly very small applications like for your watches. For all these purposes, you have these batteries, and this requires about 2 to 4 years is good enough for you, and the capacity is about 300 milliampere hour to 20,000 milliampere hour. These are the kind of batteries what people look for the consumer devices. So the voltage ranges from 1.25 to 12 volts. As you can see, for the lead acid batteries, 12 volts is very common. People look at the 12 volt batteries are very common. Next application is the grid. So what is this grid application? As you can see, what is grid? Grid means basically a thermal station you have, and you have a huge power at the grid. So what happens is you are actually trying to draw the power from the grid. As we can see, there is a grid file with power as well. So because it has got a lot of power there, and you're going to draw there. So now what is happening is that there is so many batteries which are put up. So not to pressurize the grid, because there is a peak hour and non-peak hour. In the peak hour, the draw is more, the power you draw is more, and in the normal times it will not be much. So you have to have a balance of that one. So in order to protect all these things, we need to have the batteries. When we are not using it, battery you charge the batteries. When you're using it, the batteries are ready to give you the power. So this is another very important application which are going to be very large, and sodium sulfide batteries have been using. Now people are thinking for using lithium ions here and there. And here you are not talking for 1 or 2 years. Here, once you fix it, you go for 15 years. And the capacity is not like the milliampere hour, it is in the megawatt, gigawatt. It's a huge capacity. Okay, so you see that, okay, battery remains the same. It will be the same battery like this, but I'm going to put many of them. So it will be a very large area where we are going to put these batteries. And the batteries, the voltage also, you see the 200 volts. Okay, even a single battery of not this size, rather of this one thick size, you'll be able to make. I hope I'll be able to just seeing it. Next application is going to be UPS. UPS is, you are going to see your PVs require UPS, and then many of your some of the very sensitive applications which you do, you better have a backup. So for that you use the UPS, and here you go up to 48 volts, and the battery life will not be very large, and it will be, but the capacities of the order of 6,000 ampere hour can be used. But for these batteries, you don't need a very high-fi ones. Even 50% DOD, this is the depth of discharge, can also be used. And the state of charge and depth of discharge I am going to explain you. So the other application is going to be your electric vehicle applications. So in the electric applications, definitely you can still use your lead acid batteries, but with some modifications. But still, the capacity of those batteries are going to be very low. And that's the reason energy density of the lithium-ion batteries today, nobody can beat them. So lithium-ion and lithium polymer batteries are the best batteries today available in the market. People go to China and get them, and they make it and they sell it. That's what is happening today. So the capacities, if you look at it for the electric batteries, what you have is 40 to 100 kilowatt hour is the kind of batteries what you require for that. Even 150 is possible, but depends on the kind of car you use. And the voltages you use about 100 to 200 volts. So these batteries provide I won't say 300 cycles. The requirement is much. Today is small, but the requirement is 3,000. That is for 3 years. You should not 1,000 cycles. You can put it for 3 years. 1,000 cycles is for 3 years. So if you go for 3,000 cycles, if you can able to perform, so you can give about 5 years. 5 years your batteries once you buy, because the battery cost is very large in every EV cars. So once you give it, then it should be fine. They should be fine to use it. Okay. At the same time, here again, your 8% DOD has different. So the state of charge is basically the charge which you have after whatever the life of the battery is there, the charge which is there to utilize for you, which is kind of like surge, you can say that. The energy is available for you to utilize. But you look at it, for the electric vehicle, we are putting it 80%. But whereas for the UPS, we are putting only 50%. Because for the electric vehicles, the energy hunger is very large. That's the reason where you need to have a lot of energy for this one. Whereas in the other case, the energy is not the thing. It is basically stationary applications. If you can able to store reasonably good amount with a large number of batteries, it's still fine. But for the batteries, for the cars, for the vehicles, for the any moving applications, you need to have 80% depth of state of charge, or the depth of discharge is opposite to that. Roughly opposite to that. I mean, there are different definitions of DOD, but for the time being, I'm putting it as opposite to SOC is your DOD. Okay. Next is that swapping. See, this battery, what government is trying to do is the electric vehicle may not run. What you need to go for is you need to go for the swapping of the batteries. Because I buy batteries for say about 3 lakhs or 4 lakhs of a battery, but it gets discharged as I travel. Suppose, for example, I want to travel from Calcutta to Bombay. If I want to travel, then I need to fill the fuel various places. So what government is planning is I need to have I can have battery swapping. Like you have the petrol stations, you will have battery stations, swapping stations, where you go, you give your battery there, and you take another battery, put it in your car, you can go. Like that, you can do it. But the kind of batteries and these things government is working out, and also many companies putting together, they are working out to bring out a very good scheme where swapping of batteries are possible. When you have the swapping of batteries available, then I can buy a car, because I can use the same car to go to Sabji Mandi, and the same car I can also use to go to Calcutta. Otherwise, I need to use, nowadays, many people are using two-wheelers for the battery-based ones, where the car is still the petrol-based ones. So if you want to take out that, then you need to go for this scenario. Also, it is true for the trucks and the buses. Okay, these are the bigger applications which were coming today. And now those batteries which are going to be used very well, and furthermore you cannot use it, 80% is over, I don't want to use it, then these batteries can be given to the microgrids, and for the UPS storage and those things you can use it. You can use it for some more time, and then it goes for the recycling. Okay, this is the kind of thing what we are trying to look forward to. Okay, this is a swapping policy. Now let me tell you different designs of the batteries, because designs of the batteries are also very important. For a car battery, you generally do not go for the cylindrical batteries. Of course, Tesla in one of the models, they are going for the cylindrical batteries because they are small, and it's easy to manufacture and easy to put. There are some advantages involved in that. But generally, we go for the prismatic batteries or the pouch batteries. So the prismatic and the pouch they look like this. Okay. The only thing is the way you wind these batteries are going to be different. In the case of a pouch cell, you do like a Z stacking, like that you put it. Whereas in the case of prismatic batteries, you wind like that. Okay. Very simple winding you do it. Whereas the 18650 batteries, 18650 they look like that. As I'll show. Okay. So, and you can look at the number of companies which are making goods. You can see that all these companies from outside India, none of the Indian companies are actually manufacturing batteries. I am going to come to that point a little later. Why this one? Okay. So you look at the Indian battery manufacturers. You look at it. Most of them are lead acid batteries, and then zinc carbon batteries, and nickel cadmium batteries. Most of them are primary batteries, and a few of them are secondary batteries. Nickel cadmium. Some of them are going to be secondary batteries being manufactured in India. So, but lithium-ion batteries are not yet being manufactured. Okay. Next, look at the cell. Why? Now the question comes is why? What is the problem? Why can't we just do it? When we can do with other batteries, why can't we do for the lithium? Look at the problems, and I mean, here I'm going to explain you the troubles that involved in the process. Let us look at the cell fabrication. The cell fabrication, like manufacturing of this cell I'm talking about, manufacturing of this cell, it has three components. The component one is you should have your cathode, you should have your anode, and that cathode and the anode to be prepared, like you need to coat it in the form of a film. And then you should take it to the formation of the cell. Okay, and then you have to go for the testing. There's a three parts which you have to finish, and then the batteries which are very good, they'll go off. If they're not good, they'll come back. They'll come back, and again you need to relook into the design part. Okay, so this is the three components which are very key components: cathode and anode preparation. And in cathode and anode preparation itself, there are about 5 to 6 steps are involved. And again, the formation, like the stacking, packing, and filling the electrolyte, and all these things we're doing, that is another 5 steps. So similarly, testing is another 5 to 10. So all to get put together, there will be so many steps involved in there. For example, if you look at the lead acid battery, so the steps are more or less the same. Like pure lead you take it, and the lead oxide you take it, and you grid cast you do it, and you need to paste them, and and plate stacking you do it, and you can cut it, and the cutting is done. As you can see that this is the cutting is done to the size what you require for the application, and then formation where you actually you put it. This is the way you go it, formation, and then the cutting, and then the plate stacking, and then the group welding, and then the connectors welding, and then the acid filling is going on here, and then the charging and discharging is done. So this is the kind of scenario what you have for the lead acid batteries. But however, you go for the lithium-ion batteries, you see the complication is going to go up. I'm going to show you. It involves about 16 to 22 steps or even more. Okay, so you have the mixing. First, you need to take it and you need to mix the powders very well, and then you need to coat the powders, and then you need to calendering. Calendering means you need to press them, and then you need to slit them, you need to glue them, and you need to dry them, you need to fill them, and you need to weld them, and then diffusion, crimping, tester, sorter, and everything. Most of the things to be done in the glow box. That's another very, very important thing. So what I mean to say is that the process and the cost. If you look at it for the, I have written so much of process here. You see that from the receiving the electrolyte material preparation to casting, coating the solvent and evaporation, and the solvent recovery, and of course the solvent recovery part we can forget for the time being, because we have come up, we are doing with the water, some of them these days, and you can go with the electrode slitting. And as you can see in this particular one, I have drawn something with a pink color that I called as a dry room. As you can see on the right side, the cost of using each of them. The slurry mixing is not much. Coating is not much, 1.13% of the energy consumption or the money. You have that. And the calendering is also not much. But the major portion is taken by the dry room. Why? Because all these lithium-ion batteries, if you want to make it, you have to do it in an environment where there is absolutely no water or moisture which is present. That's the reason we call it a very, very dry room. Without this, your batteries will not come up with a good quality. They die very fast. If you do a battery in a dry room, it runs for 3,000 cycles. If you do it outside, 2-3 cycles are the maximum for cycles, 5 cycles, it's done. So that's the reason why I'm saying is the dry room is extremely important, and that costs about 30% of the energy consumption, and the cost also is about 30 to 33% of the cost of the making of the batteries. So one has to be extremely. This is the main drawback why many people in India are still not able to put it. The cost is very high. To put one company, I need to go about 300 to 700 crores of rupees are required to put a start, to put a company of the battery manufacturing. However, at the same time, you can still go with the electrode material manufacturing, the separators manufacturing, the electrolyte manufacturing. These companies can come up in India very easily right now. But making the entire battery as a process, this dry room is the one which is very, very costly. Because what you are trying to do is you are going to go to the dry room and you are going to fill the electrolyte. You see what I am doing in the dry room? We are trying to, electrolyte filling is done here. If this electrolyte is exposed to the air, that's all, it's gone. It's not going to work out. Okay, so utmost care should be taken. This is the slide my boys, I'm telling you. This is the place where you are actually worried about, the processing issue of the lithium-ion batteries in a large scale. Okay. Okay. Now, if we make these batteries, do you think they are all safe just like that? No, they are not. You can see that accidents. You see the person sitting with the wound, and the car explosion due to that malfunctioning. Even in the aeroplanes, cargo carrier, it got fired because of the batteries. Lithium factory in Beijing got exposed. I mean, that got explosion. Okay, so the cyclist who is, he also the cell phone explodes and you have problem. So now you have questions. So in this process, what makes them so unsafe? That's the point we try to look at. What makes them unsafe? Can we make them safe? As I told you, the third point in the beginning, that safer batteries are important. It's not only just the cost, it's not just the chemistry, it is basically you have to put together the safety of the batteries are extremely important. And coming to this point, I just forgot to tell you. So the environmental friendly, I'm talking about, right? This process should be environmental friendly. For example, the drying and solvent recovery is 45%. Why this is 45%? Because we are using the chemical which is not environmentally friendly. These are very carcinogenic. And that's the reason it has to be completely dried up. You have to take it out. So environmentally friendly means we have to have the batteries, materials that we use should be very, very, very important. Okay. So in order to get rid of these things, and we have to go for the safer batteries, we will see first what makes them unsafe in a single step. Okay. So the handling of the batteries are very important. You cannot abuse the batteries. You cannot take the battery, you cannot throw the way you want, you cannot throw it in the water, or you say that I have something I'm playing with that, I can break it like this. You cannot do this battery. These batteries to be handled very carefully. You are in class 8 and class 9 and 10 now. So you guys should be teaching your younger boys and younger girls that batteries should be handled very carefully. Otherwise, they will go like a blast. Boom. They go like a blast. So don't play with this. It's very, very dangerous. Particularly these lithium-ion batteries with certain technology is going to be very, very dangerous. So, and also you cannot charge and discharge very fast. You put for the charging, at the same time you try to discharge very quickly by listening to or playing some game. No, don't do that. These are all not very good. So the over discharge, fast charging or over discharge itself is a problem. It is very bad. So over discharge means you are completely you are draining the battery. At the same time, you are trying to charge it. It's not good. Over voltage, you cannot do it. Over charge, you cannot do it. Over current, you cannot do it. The external short circuit, you cannot do it. What it means is that you have a cathode and anode, you cannot short circuit them just like that. Your cathode and anode things which are there, you cannot short circuit them. You cannot do that. Okay. So at the temperature, you cannot use the battery. For example, it is here. You cannot take it to a place like Ramagundam and just like that, you cannot use it because temperature is very high in summer. But also think of India. India on one side you have Ladakh, which is at minus 15 degrees or minus 20 degrees centigrade. At the same time, on the south of India, if you come to Ramagundam, is about 50 degrees centigrade. So it is true that can I use the same battery? If I want to use the same battery in Ladakh as well as in Ramagundam, then my battery should be able to take that. So these are the challenges of making the battery. Okay. So, and how it is going to catch fire? Let me tell you. So the internal short circuit is the way. What causes is the deformation, and these are a little bit of science which I will not get into too much details. So mechanical abuse or the electrical abuse or the thermal abuse. Any of them you do it, it is going to create a problem in the separator. You can see that. As I told you, cathode and anode is not the main thing. It is that separator and electrolyte which is there. That is the one which is going to cause you the explosion. Your cathode and anode is not going to catch fire, no. But your electrolyte, yes, it can catch fire. And the separator which you use, that can catch fire. So you should use something very good ones. Let me go to this. Based on this one, we can go for what is called a technology. We can write it a technology something like that. The liquid ones. which means that you can see that there is a separator where I put a lot of liquid. Okay, separator is different and the electrolyte is different here. Cathode and anode each other. And these are high ionic conductivity because of the liquid. But the leakage, flammability, unstable in air, and very high amount of prone to the loss. So this is not safe. I mean, people they don't know what the chemistry is. That's the reason why you should ask. And if you go for the gel batteries, what it means is that if they are written as lithium poly batteries, they are better. They are reasonably safe because what you're trying to do is you don't pour the liquid there, rather you only have a gel, very small amount of liquid is there. And some of the cases you still have some carbonate which are going to decompose at 70 degrees. If you take it to high temperature, it's not good, but at room temperature they are very safe. Okay, they are moderate conductivity, and only thing is you need to engineer the polymer gels for the safer this one activity. So you need to play with that. So there is a lot of research in it, and people have done good amount of research. Today's technology, from liquid to we are going to the gel, but these gel batteries are available only in the mobile phones. They are not available for the vehicles yet. Okay, and if you go for the third technology, which is people are expecting this to be there by 2025 or 2030, these are going to be the safest ones. All the people who are working in India, I will not say all the people, most of the groups working in India, they are also looking at this solid state batteries. Particularly Adyam, we are, and my group particularly, were working a lot on this gel and the solid state batteries, because these are going to be the safest batteries, where you can use the ceramics based ones or the polymer and the ceramic combination. And here your electrolyte is also a part of the same. It's not different. Your separator and the electrolyte is going to be the same thing. It's a hybrid one. It's a composite. It's a hybrid one. This is a technology which is going to be very safe. This is what, when the vehicles run on this, and you can around sit and things will be very, very good. And these are also environmentally friendly. Making these, some of them are going to be environmentally friendly. And when these batteries come up, then this is going to be really, really good, eco-friendly, as well as large capacities you will have. But there are some issues, internal resistance, and those things to be worked out a bit more carefully. So, now the third point which I am going to talk to you another 5-6 minutes, or another 10 minutes. I hope I have. I'm going to put my time on, can lithium. I talked to you so far that lithium, nobody can beat lithium. I've been telling you like that. Can lithium supply for the whole world? The answer is no. The reason is that lithium is not available everywhere. As you can see that it is available in the United States, which is only 3.6%. In Portuguese, 1.1%. In Brazil, 0.5%. In Chile, it is 43%. And in Australia, it's about 48% available. Argentina, it's available. In China, it's about 17% available. Okay, so what I'm trying to tell you is that here, in the overall, if you look at it, lithium is not available everywhere at the same time. This is only the reserves. You have to take it out and you have to put it in the form of lithium metal. You need to bring it up, or in the form of carbonate. You need to bring it up. You need to make that, process that, and then you need to use it. So the amount of lithium which is present there, even if you take the entire thing, it will not be enough for the entire world, because
Okay, that was a great presentation, and we've understood so many things regarding the battery. There's a technical error we're facing at the moment. That's why we are unable to connect to Venimadhav sir at the moment. But we'll try our level best to get connected with him once again. And so far he has discussed a lot of things regarding the battery manufacturing in India, right?
Yes.
And,
so, Professor Adyam, till you are here, till he joins us, let us continue it with it for some time. Yes. Professor Adyam was talking about the batteries, cells, and then the different electrolytes being used in those, and he is expressing more out towards the lithium-ion batteries, and trying to discuss the possibility of having lithium-ion batteries throughout for the longer time. But it's not possible because the lithium is not available everywhere. lithium is a rare earth material, is difficult to get. Now, as a matter of alternate to it, we are thinking of using sodium-ion batteries in place of the lithium-ion batteries. So, some sort of sodium which is rather easily available. You know, sodium chloride very well, we use it every day at your home in the form of your table salt, etc. And then the sodium-ion batteries can be used. If sodium can give us a good electrolyte solution to it, we can go ahead with that. Is Professor Adyam here? Not yet. So, friends, but at the same time we have many other, all of us are the students of science. So, we see dreams and that is our task. आँख खोलकर हम लोग सपने देखते हैं. कुछ सपने प्रोफेसर आद्यम हमें जब तक ज्वाइन करेंगे मैं उनसे ज़रूर पूछूंगा कि आजकल हम बात करते हैं न्यूक्लियर एनर्जी की और न्यूक्लियर एनर्जी के सोर्सेज बहुत सारे हैं. फ्यूजन एंड फिशन टेक्निक्स बेसिकली हम यूज़ करते हैं और हमारे पास जो न्यूक्लियर रिएक्टर्स हैं इंडिया में वो सब न्यूक्लियर फिशन टेक्निक्स पर है विच रिक्वायर लार्जर एस्टेब्लिशमेंट्स एटसेट्रा. It seems that he has joined.
Yes, sir. So he has joined.
So,
we are
Professor
ready
Adyam,
to ask him questions now.
Professor Adyam, we have some time left with us.
Yes. Sir, can you hear me?
Can you hear me?
Dr. Adyam?
Veni, can you listen me?
Can you hear me?
Yes,
Yes.
Veni. Since there was some technical fault in between, may I request you to kindly come directly to the sodium-ion batteries, and then I have coined some questions, and let us see how much we can take it. Please continue.
Yeah. Can you hear me? First of all,
Yes.
can you hear me?
Yes. Please continue.
Okay,
Please continue.
So the alternative is going to be the sodium-ion batteries, like I'm telling you. So this is going to, as materials itself is 13% cheaper, and when you go for further process, everything put together is about 30.
Sir?
Hello, yeah.
Yes.
Sir, you're audible, but your presentation is not shared. Would you like to share it once again? Yep. And also, sir, we have got last 5 minutes left for this entire conversation. So, would you mind making it brief, please? Okay.
So you can see it now?
Yes, we can see it now.
Okay, so this is the battery, and you look at the comparison of the lead and the lithium batteries. Still, the lithium batteries are very good. But if you look at in terms of the cost and then in terms of the application where you can manufacture in India, look at it, possibly sodium comes better than the lithium because we don't have any reserves. Okay, comparison in the price also are given you. And then these are some of the research what is done at IIT Kharagpur, where you can see that we have made some of these separators which are fire-free, and some of them which are available even at room temperature, and the conductivities are very good. The solid ones which are very good. So a lot of people are also working. Our group is also working on that one. And you can see that your NCRT book will show you this, where to look for the potential. One is going to be your sodium, and the second is sodium is here, lithium is here, very close by, and the third one is going to be aluminum, which is going to be very close here. So these are the three technologies which are possible in India. And you can see that these are the aluminum is also very good, but compared to the sodium, aluminum capacity is also high, but the voltage is slightly low. So compared to the voltage wise, sodium still I see is the better for Indian market right now. As we can progress, as we can go for the aluminum. Okay, this is the lithium versus aluminum also given because some students may be interested to look at aluminum because we have so many plants in India, so many reserves in India. Aluminum is very much available and sodium is very much available. And IIT Kharagpur, whatever we have research, that is also sodium, manganese, and iron is what we mostly look at. What is available in India, with that we can make it. And so I'll try to conclude you that 30% cheaper batteries you can make the sodium, and future will be the aluminum. But the research in the field is going to be mostly is going to be you have to be safe, and as I told you, two cost possibilities we need to reduce. The battery should be completely manufacturable at room temperature, just like that. I don't need any dry room. If you have dry room, cost is going to be very high. So these are the sort of things. Not only just the material, even the process is also very important. I can take some questions maybe during the yeah.
Sir, let me ask you a question here. We all look forward to charging our batteries in a short span of time. So how can the charging time of the battery be reduced? Are there any limits to that? And also it's being said that we wish to charge our batteries faster, apply the voltage across the battery terminals in higher values. But is there any side effect to that? Can we say that this will reduce the life of the battery?
Yeah, basically, see, the entire battery uses basically the chemistry of the battery. First, it should allow you to do that. What I showed you previously is that the road map, the road I showed you, right? Like a road I showed you. That road should be, that should not have a lot of resistance. Then I will be able to charge and discharge very fast. Okay? So now by charging and discharging, the cycling, number of cycling is also going to affect the quality of the battery. Okay, over a period of time, if you do fast charge and presently, fast charge and discharge, if you do for a very long time, if the chemistry is not allowed, then your battery is definitely going to go down very fast. But if the chemistry is allowed, what I mean to say is if it is nicely optimized, your separator and the electrolyte put together, because this is not one aspect, let me tell you. There are about 50 variables in a battery to control. It's not easy process. There are 50 variables to control. So, in principle, yes, we can design a very good battery, which is fast charging and fast discharging. We have tested in our lab for 2000 times. So people have tested for 10,000 times lithium. Yes, it is possible, fast charge, discharge is possible. But you cannot charge to 100%. You can charge to 80%, 90%. You cannot charge to 100%. Because the curve goes like that, your growth curve, how people grow. Initially it will be very fast and then it will be slow. That curve you cannot beat it.
All right. Thank you. Thank you so much, sir, for answering the query I had. And this was a wonderful presentation, like I said before. And you have given us so many tiny details about the battery that common people, even the science lovers, they don't think about it. So thank you so much for being with us. I'll request Gagan Gupta, sir, to take over.
Thank you very much, Dhani. A very enlightening session today we had, but due to some technical problem, we could not take it fully. I would have loved to ask you some more questions about the nuclear fusion energy sources in place of this electrolytes, which can give the higher life period to the batteries. And of course, can we use those batteries as reusable? I mean, by replacing electrolytes and keeping the same electrodes. So we would like to see all these questions in a subsequent session to follow in the future, in recent future. I will be requesting you again to have some more discussions here. It was really indeed very lovable and very enlightening session today. Thank you very much, Dr. Veni, and we really thank the Indian Institute of Technology, Kharagpur, for having collaborated with us for the purpose. So viewers, you had this session today on batteries. Next time on 23rd of September we are going to have a session with agricultural sciences and Dr. Arnab Sen from the northeastern hill region research complex of ICAR, that is Indian Council of Agricultural Research, will be with us in our studios, and he will be talking about the biosecurity of threats and control. Till then, let us meet again. Thank you very much.
Thank you. Thank you so much, sir. And just like you said, biosecurity threats, that is our next session, and that's going to be a really important one. If you have any questions, you can always drop in your questions through our YouTube channel, which is NCERT Official. And this was all about this particular program where we discussed battery manufacturing in India, its technological challenges and opportunities. Thank you so much to our guests. Thank you so much, Gagan sir, for being here, for being the wonderful host as always. And thank you to all our viewers for being with us, for watching this wonderful program. And if in case you have missed it, then you can watch it again on our YouTube channel. So thank you. We are taking a leave of you right now, but next week, that is Friday, we'll come back once again with the topic. Thank you once again. Take care. Namaskar.